Imagine a navy without sailors on board, boats that roam the ocean by themselves, gather intelligence, even launch drones, no captain, no crew. It sounds like science fiction, but uncrewed surface vessels or USVs are already here and evolving at lightning speed. Today we'll explore how these autonomous ships are getting smarter, faster, and far more flexible, and why that matters for science, commerce, and national security. First, what exactly is a USV? Think of a boat or small ship that carries sensors, cameras, and sometimes weapons, but no humans on board. Operators can control it remotely or let advanced software navigate and make decisions on its own. This cuts costs, removes crews from danger, and allows operations in places that would normally be too risky or expensive. Take Taiwan's new Manta USV. Built by CSBC Corporation, it looks like a sleek trimaran and is designed for coastal defense. Every critical component is sourced outside China for security reasons, and the software is a joint venture between Taiwanese and international firms. What makes it stand out is a wide rear flight deck where drones can land and take off, and an internal bay to carry even more aerial drones. It's essentially a floating drone carrier that can patrol Taiwan's waters without putting a single sailor at risk. Across Europe, a very different kind of USV is making waves. The C-RECON 13ES from Subsea Europe Services is a 4-meter all-electric vessel built for science, not war. It can map the seafloor, monitor the environment, and inspect offshore wind farms. Its secret weapon is speed of setup. A plug-and-sail hardware backbone, tool-free deck mounts, and a universal underwater payload interface mean scientists can load their sensors and launch within minutes instead of hours. The United States is going bigger. HII's ROMULUS 190 is a 190-foot giant capable of more than 25 knots and 2,500 nautical miles of range. Its open deck can carry 4 full-size shipping containers, letting the Navy swap out payloads for different missions. Anti-submarine warfare one day, disaster relief the next. Driving it all is the Odyssey autonomous control system. Software already proven on more than 35 platforms and 6,000 operational hours with U.S. and allied forces. Odyssey allows multi-vessel swarm operations where several USVs coordinate like a single organism. The innovation doesn't stop there. British firm BMT is developing Modus, a family of medium and large USVs up to 75 meters long, aimed at seabed warfare and offshore survey work. In California, live demonstrations are testing networks of USVs, aerial drones, and smart sensor buoys, working together to detect submarines and surface threats. It's a glimpse of an ocean filled with cooperating robots. Why should we care? Because modular, rapidly deployable USVs slash operating costs cut human risk and open new missions, from mapping fragile coral reefs to tracking illegal fishing or carrying relief supplies after a hurricane. For militaries, they offer persistent surveillance and the ability to project power without risking lives. But this also raises serious questions about maritime law, cybersecurity, and how nations will control or counter swarms of autonomous vessels. Whether for science, commerce, or defense, the oceans of the next decade will be patrolled not just by sailors, but by fleets of intelligent, crewless ships. From Taiwan's drone-launching Manta to America's massive Romulus, the message is clear. Autonomy at sea is no longer the future, it's the present. How governments and international laws adapt to this silent revolution will shape the balance of power on the world's oceans.